Hello, I'm Derek Hitchens, but for the purposes of this particular presentation, let's pretend that I'm Hemiunu, architect to the great king Khufu. What was Khufu's vision of the then bare Giza Plateau, where he wished to be interred in a magnificent complex? In his mind, it probably looked something like this. It was on the west bank of the Nile, and there was, of course, the pyramid, Khufu's horizon, or Akhet Khufu. There would be smaller Queen's pyramids, a Temenos wall and courtyard, a mortuary temple, a covered causeway for ceremonials, a valley temple, Pharaoh's Ka pyramids, and the city of the dead's nobles' tombs. And of course, because we were in the middle of switching over from a stellar to a solar mythology, there would be solar boat pits buried in several spots. So it would appear there was much more to any pyramid complex than just the pyramid. The complex was a psychic projector to preserve and project the king's Ka, his psyche, to the netherworld so that he could negotiate with the other gods by night to ensure a good inundation, on which the whole of Egypt, Chemet in their words, depended, and also to oversee and protect his people throughout Upper and Lower Egypt by day. The architecture of the pyramid had to serve these essential purposes of the dead king, as well as preserving his remains, his mummy, in his sarcophagus. The energy to drive this enormous psychic projector was to be provided by a full-time priesthood, with offerings, lustrations, prayers and ceremonies to support, enable, project and recover the king's Ka. The architecture of the pyramid complex as a whole had to support the priesthood with their ceremonies both during the interment and for 1,000,000 years after. Akhet Khufu was to be a living, breathing, functioning organism for all time, rather than the naked, partially demolished stone structures we see today. Over several hundred years, they had developed the ability within ancient Egypt to build in stone, and they had built many pyramids previously, particularly during the reign of Khufu's predecessor, King Snefru. He had built pyramids at Meidum and notably at Dashur, and the pyramid design had evolved partly from trial and error, to be honest. And the basic pyramid idea was something like this shown in the diagram. There was an innermost part, a step-like core. Now this core consisted of a number of concentric shells. The sloping bands were all carefully finished so that they were able to slip relative to each other, and as a result they had become earthquake-proof. Outside of the shells there were packing blocks to fill in the steps, and then casing blocks of white Chura limestone on the outside to give the impression of impregnability and purity. Oh, and the capstone was probably going to be made of gold. We architects love little gimmicks like this one, an architecture fly-around. And that showed the sequence of events in rather rapid order. Notice the gold pyramidion at the top. That's Khafre's pyramid. And this is systems engineering, Egyptian style. So, models, plans, and the all-essential operations research, which in this case will be carried out really by dynamic modelling. This is Hemiunu's plan, my plan if you like, system creation without reduction. And we can see that things happen in some sort of order: 1, 2, 3, 4, 5 and 6. So 1 is establish the customer and user wants and needs. We've seen some of that already because they contribute to conceiving a future vision with the customer. Khufu. 3, establish the emergent properties of the future vision. 4, conceive strategies to realise the requisite emergent properties. And 5, select, correlate, resource and pursue effective strategies to realise those emergent properties. And in the doing of that, we will realise the future vision. Quite straightforward, but there's no reduction. It's all synthesis from the word go. So, conundrums. How long to raise a pyramid? How many workers? Will those workers work all the year round or just during the annual corvée, which was expected to take place during the inundation? How to engineer the pyramids? Would they use long ramps, wraparound ramps, etc.? Or something else? Perhaps contrivances made of short timbers? So, this operations research. Let's have a look. There's an obvious planning and construction problem, even allowing that I, as the architect, have chosen to build with much larger stone blocks than in previous pyramids, thereby cutting down the number of blocks. Raising Khufu's pyramid will still take 2.3 million stones at about 2.5 tons average, and that will take 20 years, going at 360 days per annum, 10 hours per day. So 36 stones per hour continuous on average, but that works out at being about 90 tons average per hour continuous for 20 years. That's some loading. And during the early phases, it's going to take 200 tons per hour or more in early construction to achieve the 90 tons average long term, because once you get to the peak of the pyramid, towards the tip, you can't load up at 90 tons or anywhere like it. So on average, 200 tons per hour in the early construction area. How can we possibly raise such enormous amounts of stone? And of course, if one watches lots of Hollywood movies, you end up with the idea that the answer obviously is a ramp. Ramp series. What have we here? The ramp slope, by experiment, has to be less than about 8 degrees. Any greater slope and it becomes too difficult to haul the stones against the severe friction. Ramp remains have not been found at Giza. They have been in other places, and particularly near quarries, but not at Giza by the pyramids. And you can see from the diagram and from the previous video that straight ramps can become enormous as the tiers rise. The whole ramp has to be raised in order to not exceed in the slope. You can't just raise the bit near the pyramid. So straight ramps are out. So the ramps could progress around the pyramid, one from each corner, or zigzag on one face as shown. Note the need for substantial corners to turn stones, which if they're being dragged on sledges, could be anything up to 33 metres from start to finish, which makes for a big corner. As the tiers rise, also, the slope length shortens, and either ramps will become too steep or the tiers must become progressively shorter and stubbier. And then there's the actual ramps construction. They would be constructed by tradition from limestone chippings, with logs inset to reduce sliding friction. But we hadn't invented the wheel or the rotating ramp back then, so the runners would be fixed, and the logs would be lubricated with water or quicklime. Would a ramp built like that sustain more than 90 tons per hour for 20 years? It really doesn't stand up, does it? So there are too many unanswered problems with the notion of using ramps for such a large structure over such a long time. And that's in addition to there being zero evidence of any ramps having been built or used at the site of Khufu. So there's no remains, nothing. Perhaps it's time to dispense with the whole idea. Back in 440 BC, which is going to be way ahead of my time, of course, the pyramid was built in steps, battlement-wise, as it is called, or according to others, altar-wise. After laying the stones for the base, they raised the remaining stones to their place by means of machines formed of short wooden planks, which can also be translated as contrivances made of short timbers. The first machine raised them from the ground to the top of the first step. On this there was another machine which received the stone upon its arrival and conveyed it to the second step, whence a third machine advanced it still higher. So, contrivances made of short timbers. This is one, and this process is sometimes referred to as cribbing. You can imagine men on top of the beam going from one end to the other to tip it. Or we can use a rocker sledge. Both these methods are slow but steady and can be very effective. And then the rocker is used to move the stone as well. If we imagine the stones being moved without the men, it might look rather curiously something like this. There's 3 teams in parallel, raising stone with another team behind, raising more stones, and so on. Tier upon tier. And so we can consider parallel working using this cribbing method. And as you can see, we could have as many as 40 teams, each raising about 2 tons per hour, which is steep but feasible. And if it's working on all sides, it might look rather crudely something like this, all happening at once. So, needs, requirements, and emergence. Let's look at the central concept of emergence. Emergent properties are those properties of a system as a whole which cannot be ascribed completely to its individual component parts. And as an example, let's look at vehicle emergent properties. They can be physical properties, functional properties, temporal properties, aesthetic properties, behavioural properties, and value properties. We shall look at some further. So, for number 1, we're looking to have a numinous open-air cathedral for the worship of the king and regular religious ceremonies. 2, a site to legitimise succeeding king as Khafre Horus and safeguard the dead king as Khufu Osiris, and to maintain his ka. And the pyramid to annually revitalise the celestial seed for all of Egypt, giving rebirth with each annual inundation. 4, a grand plan for Giza to reenact part of the star and, more lately, solar mythology on Earth. 5, to create a large gold-tipped white pyramid sighted on the horizon to represent a place of resurrection. 6. That pyramid to be very large, to impress, perhaps to mark the spots from heavens, defeat robbers, contain traps, decoy chambers, yet support regular ceremonies of rebirth, of offerings to the Ka, etc. Akhet Khufu to contain protective magic symbols, relationships, angles, but within a sound, impregnable, yet functional architecture. And this is not very different from our Christian cruciform cathedral facing east in concept. And we can look at each of those emergent properties in turn, and we can look at the strategies and principal activities to achieve those emergent properties. And you can see them on the right. Number 2, site to legitimize succeeding king as Khafre Horus. Khafre would be Khufu's son, and to safeguard the dead king as Khufu Osiris. It was part of the legitimization that as the king died, he went from being Khufu Horus when alive, he transmogrified into Khufu Osiris when dead, and his son took on the role of Horus, so he became Khafre Horus. He, when he died in turn, would become Khafre Osiris. And it was this handing down from father to son to father to son, from Horus to Osiris, from Horus to Osiris, which legitimized the king. The pyramid annually revitalizes the celestial seed. Giza and pyramids to contain magic symbols. The pyramids to be very large, to impress. And there are many here, many strategies and techniques, including building one or more models of the pyramids, or perhaps parts of the pyramids, as we shall see. This is a section through the Great Pyramid as we might see it today. We would see the slope as being about 51 degrees 52 minutes. There's a Queen's Chamber, a King's Chamber, a Grand Gallery, which we see as storage for passage plugs. There are passages downwards and upwards. There's an escape tunnel and a deserted lower chamber. There's a shaft that was explored by a robot recently by a young man called Rudolf Gantenbrink, and he found a door up towards the end. The passageways and the Grand Gallery all slope at 26.5 degrees, and there are chambers, Queen's Chamber South and Queen's Chamber North, coming from the Queen's Chamber, and King's Chamber South and King's Chamber North, coming from the King's Chamber. Perhaps a little more to it than we might at first have envisaged. Those shafts that I've just mentioned, star shafts perhaps, align with the culmination points of a number of distinctive stars. Alnitak, which is in Orion, Sirius, which is the brightest star in the sky, Kokab in Ursa Minor, and Suban, which then was the pole star. The combination of Kokab coincides with the heliacal rising of Alnitak, or Orion or Osiris. Kokab was perhaps to be Khufu Osiris's final resting place in this stellar mythology. Here we see a chart set to 2450 BC, 7th of June 456, and from that we can see that as Alnitak rises to the horizon, right now so does the Sun. And once again, Orion's nebula and the belt on the right, Alnitak goes up, and once again, there. Notional Great Pyramid internal structure. You'll find now that the measurements are all in Seked, which you can relate to angle. A second is given by 7 divided by the tan of the angle. So 7 divided by tan of 52 degrees gives you 5.5 seconds, which is the pyramid slope, bottom left-hand corner. You can see that from the Queen's Pyramid we have 2 star shafts, both at 8.5 seconds. From the King's Chamber we have an asymmetric setup with one star shaft going to the south at 7 seconds and the other going to the north at 11 seconds. And we now know that they all point at particular stars. I've shown a level there which is not obvious, called the Mound of Creation, which cuts across at the uppermost region, separating the upper from the lower. Part of ancient Egyptian mythology was that from the primeval waters there emerged the initial Mound of Creation. And this probably happened in Rostau, which is otherwise known as the Giza Plateau. And so it's supposed that this pyramid reconstructed the Mound of Creation and then kept going to build a pyramid on top of it. And that's what's shown here. Let's look at those principal structural alignments in perspective, because the internal structures are very much coplanar. We can see the Grand Gallery, the Queen's Chamber, the King's Chamber, and the 4 star shafts. Notice that the northern shafts, the 2 facing us, the northern shafts, curve around the Grand Gallery, so they couldn't be used for star sighting, as some people have suggested. There's a list of the annual ceremonies which coincide with the various culminations, and it can be seen that the whole is an annual fertility rite to maintain the fertility and fecundity of Egypt forever. Now let's look at the architecture from an architect's viewpoint. We can see here a view, and the first thing we notice is the use of 40 cubit measures. So the height of the pyramid is 7 40 cubit measures, which is 280 cubits. Whereas the half width of the pyramid to the centre line is 5.5 times 40, which is 220 cubits. Now we've already seen that the slope of the pyramid is 5.5. And if you look at that, it's 5.5 times 40 over 7 times 40. And that is the cubit ratio, giving you the second slope. If we start looking at the vertical budget, we can see that above the internal mound that would already exist in there, we get up to the bottom of the Queen's Chamber passage with 43 cubits. Now the next one, the 40 cubits, is the height of the Grand Gallery, and it's the distance between the Queen's Chamber's passage and the King's Chamber's passage. And the Grand Gallery is 40 cubits high and 80 cubits wide. And then above that we have 2 lots of 35 cubits and 35 cubits going from the King's Chamber's passage to the top of the mound, and from there up to the underside of the top pyramid, which some people believe is the equivalent of a benben, of which more at another time. Now you can see that this is a little complicated. You can see that there are 200 cubic measures at the underside of the benben, but also it looks like the top of the mound has got a 200 cubic measure on it. To unravel this and see what's going on, let's look a bit closely, and let's look at the Queen Chamber's level just extracted from that diagram. 200 cubits wide, so 100 cubits half width. The 2 star shafts are both at 8.5 seconds, and there's the Queen's Chamber at the bottom, and there's an apparent anchor point just under the Queen's Chamber which aligns both shafts. Very symmetrical, and I've done the calculation of the drop using the Egyptian method. That would be 7 divided by 8.5 times 100, which is 82 and 6/17 cubits. And that has to be precise to give you the correct slope. Now that was symmetrical, but the King's Chamber is anything but symmetrical. In fact, the whole of the King's Chamber and the relieving chambers and the cap on top are all shifted off by a mean 22.22 cubits to the south, to the left in this picture. And you can also see that by doing that and having the right drop, you get the 7 seked to the left, to the south, and the 11 seked to the right, to the north, coinciding with another anchor point just underneath the King's Chamber. And the vertical drop has to be precise again. That's 7 over 11 plus 7 times 200, which is 77.78 cubits. This is delightful work, very accurate and quite elegant. So how did they go about building that grand gallery? Well, we'll have a look at that in a bit more detail, because this has puzzled people for many years. In figure 1 you can see that there are 2 ramps. They're brown. You can see the 2 ramps on which there are 2 cobblestones in grey. And to either side of the ramp there are building walls. The idea is to raise the stones up onto the building wall and then slide them across onto the ramps. And you can see that in figure 2, where the building walls have been raised and stones have been cobblestones have been raised up on those and then slid into position. Probably a lot easier to say than it would be to do. In figure 3 you can just see what's left of the 2 ramps on either side of the small entrance at the bottom to the Queen's Chamber, which is in the masonry at the back. And then at the right you can see the whole thing put together and assembled. Another look at it in perspective, and you can see the rising passage, centre right at the bottom, going into the Queen's Chamber, and the actual Queen's Chamber is obscured in the masonry, but you can see the beginnings of the corbels to left and right of the passageway going upwards. Another view a little bit later on, you can see 4 rows of corbels beginning to get into place, and a staircase having been put in the middle. And finally, removing the building walls so that you can see, there's the complete grand gallery from the outside. It's lit from the inside to help you see. And at the top we have the King's Chamber, which you can't quite see, but you can see the relieving chamber, so-called, above it, and the pent roof of the King's Chamber. Splendid bit of work. Let's go look at the construction process in model form, but dynamic. That's the Queen's Chamber. We obscure the Queen's Chamber, we build it in, raise all the bits. Now let's watch that undo, because it's easier to see what's going on when you undo it. Take the building walls down, reveal take all the bits off of the corbels, and there's the Queen's Chamber and one of the passageways sticking up to the right. Again, build the building walls and raise the stones, and raise all the stones and cap it, and then build it in. So Khufu's Corbel Grand Gallery, it's enormous, and it's a masterpiece of the stonemason's art in this or any other age. Looking up and looking down, you can see the corbelled arch right at the top. You can see that each of the corbelled stones has been brought in by quite a gentle amount each time. And you can also see the remainders of the 2 ramps, which in both photographs are supporting the railings, left and right railings either side of the staircase, although of course the railings are modern. There's a Gantt chart showing the building of Khufu's Great Pyramid. This is based on experience with the building of other pyramids, of course, and the sequence is correct, but of course there's very much an estimate of man-hours per job and an estimate of the size of the workforce. So Khufu's vision in operation as he would have imagined it working. You can see Queen's Chamber, the Grand Gallery and the King's Chamber, which is now presented as a created netherworld. You can just see the King's sarcophagus in the chamber. So by night, Khufu would be in his King's Chamber and he would be free to roam to the southern netherworld by his star shaft or to the northern netherworld by his star shaft, both of which are presumed to go to the outside and to pierce the outside of the pyramid. By day, well, he would come down the Grand Gallery, in through the passageway into the Queen's Chamber, and from there he could, using the two shafts, he could visit either Upper Egypt or Lower Egypt. And that's one of the reasons the shaft angles would have been exactly the same as each other, to give parity between Upper and Lower Egypt. And once there, he would roam Upper Egypt or Lower Egypt, make royal progressions, watch over the people, and maintain Ma'at, which is the peculiarly Egyptian concept of harmony, cosmic harmony, for which the king was ultimately responsible. A magnificent concept, and who's to say it didn't work? And that was systems engineering, ancient Egyptian style. Well, very probably. Thank you for listening.